Dear students, welcome to you all in mathematics class. Today we are going to discuss about equations, and this is third lecture on equations. And today we are going to discuss about a new topic, which is indicial equations. So today's topics are introduction to indicial equation, expressing as powers, solving indicial equation of one variable. Now to start learning about indicial equation, we have to learn some basic definitions and we have to answer some questions. The first question is, what is an indicial equation? Second question may be like this: give some examples of indicial equation. And third question: which basic property of index is often used for solving an indicial equation? That is, what is the basic technique of solving an indicial equation? To answer the first question, an indicial equation is an equation in which variables are found as index or exponent or power. Answer of the second question is, give some example of indicial equation. It may vary to person, like 2 to the power x is equal to 8 is an indicial equation because the variable x is appeared as power of 2. You may write like 3 to the power x is equal to 8, also an indicial equation. Similarly, you can see two examples: 3 to the power x plus 2 minus 3 to the power x minus 27 equal to 0, and 16 to the power x equal to 4 to the power x plus 2 are examples of indicial equations. So which basic property, that is which basic technique we are using to solve indicial equation? The frequently used property of index to solve the indicial equation is as follows: if a is greater than 0 and a is not equal to 1, then a to the power x equal to a to the power m, if and only if x equal to m. This is the basic technique. To explain this, look at this condition: a is greater than 0, a is not equal to 1, then if a to the power x equal to a to the power m, then you can write x equal to m. That is, if we can express an equation in this form, then we can write this line: if bases are the same at both sides, then powers will be same on both sides. But base cannot be less than equal to 0 or cannot be 1 here. So next topic is expressing as power. Expressing as power is a very vital concept or technique that you have to learn, because if you cannot express some number as power of another number, then you cannot solve indicial equation. You have to learn this technique. So in your textbook you have some work like this: work 1, express 4096 4096 in powers of half, 2, 4, 8, 16, 2 root 2 and cube root of 4. Express 729 in powers of 3, 9s, 27, 16 and fifth root of 9. Express 64 by 729 in powers of 3 by 2 and cube root of 3 by 2. So let's solve some of the problems and see how can we express a number in terms of power of any other number. Suppose you have to express 81 as the power of root 3. Then what is the technique? We'll take 81, then 81 equal to 3 to the power 4, then 3 can be written as root 3 square, that is root 3 square whole to the power 4, and indices are multiplied here, therefore root 3 to the power 8. If you are to express 729 as power of 16, then what to do? You'll write let 729 equal to 16 to the power x. From your math book you have learned about logarithm, so you know that if this kind of equation occurs, then you can write this power as logarithmic terms, like x equal to log of 729 where base is 16. You can find this value using calculator. This value will be an irrational number. Now suppose you have to express this kind of fractional term as the power of 3 by 2, like 64 by 729 as the power of 3 by 2. So let 3 by 2 whole to the power x equal to 64 by 729. Now we can express 64 as power of 2, that is 2 to the power 6 and 3 to the power 6. Then 2 by 3 whole to the power 6. Now here we have 3 by 2, here we have 2 by 3. If we want to invert this fraction, then we have to introduce a negative power or negative index, that is 3 by 2 whole to the power minus 6. Now look at this fraction 3 by 2 whole to the power x, and here we have 3 by 2 whole to the power minus 6. 3 by 2, 3 by 2, base and base, they are equal, therefore x equal to minus 6. Now we are going to solve some problems, and by solving these problems we are going to learn about the techniques we have to use to solve indicial equations. Look at these three indicial equations. First one is solve the equation 5 to the power 3x minus 7 equal to 3x minus 7, 3 to the power 3x minus 7. And second problem is solve 5 to the power 2x into b to the power x minus 3 divided by 5 to the power x plus 3 and equal to a to the power x minus 3, where a b is greater than 0 and 5b is not equal to a. And problem 3 is 5 to the power x plus 5 to the power 2 minus x equal to 26. So we are going to see what is the solution of first problem. So first we write the problem. Now we will divide the both side with 3 to the power 3x minus 7. You get this line, and then we can write this line as 5 to the power 3x minus 7 and 3 to the power 3x minus 7. This part becomes this 5 by 3 whole to the power 3x minus 7, and 1 can be written as any number to the power 0. So here, to make sure that the bases are equal, we can write 5 by 3 to the power 0, because we have 5 by 3 as base at the left side. We have taken 5 by 3 as the base of the right side. Now here 5 by 3 to the power 3x minus 7 and equal to 5 by 3 to the power 0, therefore 3x minus 7 equal to 0. So we will write that 3x minus 7 equal to 0, 3x equal to 7, or x equal to 7 by 3. So the solution is x is equal to 7 by 3. So we are going to solve the next question here. So we have written the problem here. Solve 5 to the power 2x b to the power x minus 3 divided by 5 to the power x plus 3 equal to x to the power x minus 3. Where conditions are a b is greater than 0 and 5b is not equal to a. So we will use this condition So what will be the solution? We will copy the question 5 to the power 2x b to the power x minus 3 like this. Now we have written the given equation in a simplified form, that we have taken away the different terms. Look here, we have taken 5 to the power 2x divided by 5 to the power x minus 3, because we can calculate this term or simplify this term, but we cannot simplify b to the power x minus 3. Therefore we have taken b to the power x minus 3 uh, as separated one. So here we can write that 5 to the power 2x minus x minus 3. As we divide 5 to the power 2x by 5 to the power x plus 3, 5 to the power x plus 3, therefore this x plus 3 will be subtracted from the 2x, and therefore 5 to the power 2x minus x minus 3. And now we'll see that 5 to the power x minus 3, b to the power x minus 3, and also a to the power x minus 3. 5b to the power x minus 3, then because power are same, so powers are taken as common power, 5b to the power x minus 3. Now we will divide both sides by a to the power x minus 3 equal to 1. Now you can write 5b by a to the power x minus 3 equal to 1. 1 can be written as any base to the power 0, therefore 5b by a to the power 0. Now we can write, as the bases are same at the both sides, therefore the powers are same, and therefore x minus 3 equal to 0. Now x equal to 3. Therefore the solution is x equal to 3. Now my question is, what was the necessity of this condition for solving the equation? You have to find it out by yourself. Now we are going to solve the third problem, another type of problem here. So solution, look at the question, 5 to the power x plus 5 to the power 2 minus x equal to 26. So firstly we will simplify the equation 5 to the power x, 5 to the 2 minus x. Now 5 to the power x, see, we have written 5 square by 5x. Since 5 to the power 2 minus x here, we have broken down this term into 5 square by 5 to the power x. Now we have written that y plus 25 by y equal to 26. Why? We have taken in consider that y is equal to 5 to the power 2x. Let 5 to the power x equal to y. Now we can multiply the both sides with y. Now we can take all the terms at the left side, and arranging with respect to the powers, we can write y square minus 26y plus 25. Now this equation is clearly a quadratic equation, and we can solve this quadratic equation by middle term, or by um, the general law of solution of quadratic equation, whatever you want. I have used middle term here. Now I'm going to write it like this. Y is equal to 1 or y equal to 25. Therefore 5 to the power x equal to 1 or 5 to the power x equal to 25 means 5 square. we have substituted y, x equal to 0 or x equal to 2. Therefore, the solution is x equal to 0 or 2. If you can solve these three problems, then I hope you can solve the next problems. And in your book you have a bunch of problems. Among them I have solved problem number 2, problem number 7 and problem number 9. So you can solve problem 1, problem 3, problem 4, problem 5 as same as problem number 2, same, they are of same technique, and problem 6 and problem 7 are of same technique. Problem 8, 9, 10, 11 and 12 are of same technique. So I hope you can solve whole of the problems. If you have any confusion or if you have any further problem, contact me through email. And that's all for today. See you in the next class. Keep yourself safe and sound. Goodbye.